Welcome to Section 3, the motion of astronomical bodies. Here in our picture for the day, we have a wonderful example of retrograde motion. And this we'll see sequence images showing Mars as it's going through its prograde, then retrograde motion. And this will be over a couple of days. And along with that, in this case, because of the alignments, you can actually see Saturn going through its retrograde motion. So with that, let's just dive right into the material and ask our reading quiz question. What is the amount of time it takes for a planet to orbit the sun? What period is that? What is that period called? So pause the video, take a moment, come up with your answer, and then come right back. All right. We can immediately rule out things like our prograde and retrograde motion. If you were paying attention at all, you heard me say those things in reference to the motions of planets. It doesn't refer to the time of their motions. And logic things out, you can probably get rid of Geocentric Model that refers to an Earth-centered universe. So you're left with this synodic and sidereal periods. And these are both very real periods, and we're going to discuss them in detail in this video series. And I'll leave you off at the sidereal period. That is the time to orbit the sun. A shortcut that I like to use is that it's the real period. Now, take that with a grain of salt, and we'll define these shortly. In this section, we're going to build up our heliocentric model. We're going to expand away from the geocentric idea, how we went from thinking the Earth was the center of the universe, to the incremental observations that led us to a sun-centered solar system. Initially, it was a sun-centered universe, but we've since grown in our understanding, and now we know it's a sun-centered solar system. And from that, we'll build up to Kepler's laws of planetary motions, and at the very end, Newton's laws of motions. And we'll find that Newton's work replicates Kepler's work. Kepler's work grew out of understanding the heliocentric model. From our viewpoint on Earth, the entire universe is constantly orbiting around us. And so we built up geocentric models where Earth was the center of the universe. And I love pictures like these. There's a lot of details here that early astronomers were getting correct. So in our geocentric model, Earth would be here in the center, and the universe itself goes out in expanding rings. And one of the ideas, and philosophically, was that for the universe to exist, it had to be perfect because, well, we exist. Kind of a circular logic, but that was the resounding philosophy. Things had to be nice, perfect circles because that was the perfect shape, the perfect universe. And so we assumed that everything did these nice, perfectly circular orbits around us. Another thing I love about this picture is the order of things. We go on Earth, you can see these a little bit Latin. It's the moon, Luna, Mercury, Venus, Solus, our sun, Martians, the Mercuries, Jupiter, Saturn, so on and so forth. And I love that the sun is the third object away from us, skipping the moon. Then, if you think about this was the early astronomers putting the universe to scale, putting things in the solar system in sequence, but they have Earth and the sun flipped around because of the distances between us. And I always love the weird quirks like this when you're working with the wrong assumptions, but how many correct details you can get, how the sun is the third object. Now, on top of things orbiting in these perfect circles, here we see it again, everyone is orbiting around us in these perfect circles. The planets had this thing about their retrograde motion. They would go in the wrong direction at times. And we needed a way to explain that. So Ptolemy, he developed a system that lasted for almost 2 millennia. And his idea was these epicycles. In essence, you would take a planet, let it orbit around Earth, and then on top of this orbit, the orbit around us, it would have an additional epicycle. And the epicycle would be the planet going in perfect circles again along its orbit. So the path of the planets is actually something crazy like this. As it's going around, it's doing a perfect circle around its orbit as it's doing a perfect circle around us.